So in this video we're going to look at how we can generate our own normal curve, and since we understood that any random distribution can be turned into a normal curve just by following the central limit theorem, understanding of the normal curve itself is quite important now, because it is the central area we're going to work with, since we understand that we can generate it no matter what from the sample means. Alright, so for us to see how this formula works, because we've been seeing normal curves only as a picture, but now we're going to see it in terms of the formula itself. So I have the formula here ready for us. This is not mine, I just grabbed it from the internet, but it is a form that we will use. The mean, I specified it, but we can try and change it later on when we understand how we plug things in the formula, substitute and see what we get from it. Alright, so first let's build our formula using Excel. So we have, according to this, we have 1 over sigma means standard deviation, so it's 1 over the value of the standard deviation. Let's make sure that that doesn't move, and for us to do that you need to put a dollar sign on in front of the letter and in front of the number also, and then multiply it to the square root of 2 times pi. So it's 2 times pi, which is, let's just round it off to 3.1416 right there. So that's good enough. Let's don't forget about our close parentheses. And now this entire coefficient is multiplied to e right there. So it's multiplied to an exponential, which means exp, and inside of that exponential we need to plug in the arguments, which is minus x minus mu 2 sigma squared. I mean, to greatly simplify this, I can just take out the 2 there and turn it into a minus 0.5. As you can see, that's 1/2 negative multiplied to, as you can see there, it's x means the value of our x, which I'm sorry I forgot to put. Maybe I'll just put it right beside here later on. So I'm just going to supply this, this thing, that will be our x. I'll fix it later on, minus mu, which is the mean, and make sure that that's constant also. So put a dollar sign, and that thing is supposed to be divided by, this thing is supposed to be divided by the sigma, which is the standard deviation. So it's this guy again. It's going to be the dollar sign and the dollar sign, and you can see that that entire thing is squared. So this to that needs to be squared, and let's press enter. So that's our value. Let me move it right here. That's the value of our function. Let's call that the standard function s of x, and let's call this thing x. So it depends on where you want to start on. Since our mean is 10, so we can start on the left side, or the far left side, and since our standard deviation is 1, we can try and start maybe 7, like 3 standard deviations away. So that's our 7. Let's make sure that the formula is correct. See, it's taking this value for the x, so let's change that to this. Alright, I think everything is clear, and let's approach the mean, 8, 9, and let's just drag this down so it's easier. 10, 11, 12, 13, there, that's 3 standard deviations away from. Alright, and let's just drag this down there. Quite fascinating. Now, of course, there's just a few amounts of data around it, so better maybe if we just increment by 0.1 so we can see much clearly what the curve would look like. So let's try that out. Increment by 0.1 until we reach 13. Alright, I'll just go below and see until I reach 13, and that's the mean. Quite further, even further, almost there, 2 more, and there you go. And then let's just tell this to fill in all the gaps. Alright, and then the next step in this analysis is for us to have the graph itself. Alright, so I want you to notice something, and one of the behaviors I've been telling about in the normal curve is the statistic. Statistic means this x value, the ones that you put in a function, that's a statistic. In a normal curve, the statistic with the highest probability is always the mean. Alright, so let's check that idea out by plotting this result. Alright, so I'll go insert and select for this connected dots right there. Oh, that's quite nice. Okay, let me just make it smaller so we can see what's happening. Alright, yes. That is certainly a normal curve, as you can see. Let's remove the chart title, we don't really need that. There you go. Alright, I just made it bigger, and here it is. This is our curve right there. As you can see, the mean that we specified a while ago, which was 10, you can see in there, 10 value is exactly at the highest probability. And so by using the central limit theorem, we understand that since we can turn any kind of weird distribution into a normal distribution, and once we have the normal distribution, we can just find the highest probability in a normal distribution, and that would correspond to our mean. I hope that's quite clear for you guys. So see you again in the next video.